Okay, so the question that I'm going to look at is question 6 from page 403 on the topic of surface geometry. So it says the figure 16.55 shows the plan and elevation of a lean-to roof. Surface A has a pitch of 30 degrees. Okay, so I'll just write that there. Surface B has a pitch of 45 degrees. And surface C has a pitch of 60 degrees. Draw the plan and elevation of the roof. Develop the surfaces A and B. Find the dihedral angle between the surfaces A and B. Okay. So we've looked at a dihedral angle already. So the dihedral angle is the angle between two planes. So if two planes share a common line, which is the line of intersection, the dihedral angle will be perpendicular to the line of intersection. So it's the angle between the planes. We've that looked at already when we were looking at the topic of oblique planes. What we need to look at now with this surface geometry is we need to look at the whole idea of pitch angle, okay, and the pitch of these surfaces. So I just have a little sketch here that I'm going to go through first before I start into the question. So with a lot of these questions, you're going to be given the pitch angle and the length, and you won't be given the height of the surface, or maybe you may be given the height and the length, or you might be given the height and the pitch angle and you'll have to figure out the length. So out of these three different parameters, you will be given 2 out of the 3, okay? But if you're given the pitch angle and the length, that means you don't have the height, which is the elevation, so you won't be able to draw the elevation. Maybe you might be given the height and the pitch angle, meaning that you may not know some of the lengths. Okay, we'll go through it as I'm going to go on doing this question. Okay, but just keep that sketch in mind. So the height is the height of the surface, the length is how long the surface is, and the pitch angle is the angle that it makes to the horizontal plane, or the plane that it's resting on. Okay, so the first thing is the width of surface B and C in plan view is 5 meters. So 5 meters to scale is 50 millimeters. So I'm going to mark in that angle there of 50. Surface C is at an angle of 60 degrees in plan. So that's surface C. So it's at an angle of 60 degrees, and we know that the width of it here is 5 meters. Now we know that in elevation then, that from this point here on surface C to the other point on surface B is 12 meters. Again, we don't know the height of A, B, or C in elevation. Now, one thing that we do know is the pitch angle of surface B. So the pitch angle of surface B is 45 degrees. Now, in order to be able to see that true pitch angle, you have to look in at the side of B to get an edge view of that surface. So B is located here. So to get an edge view, we're going to look in from this side here, and we're going to project out an in view over here. It says that the angle is at an angle of 45 degrees. That's an edge view of B with an angle of 45 degrees. Okay, so because now we're after putting in that angle of 45 degrees, we have the length, and what that's given us is given us this height here of B from the ground. So we can take that length now in our compass and that's the height then of surface B in elevation. And we can draw a line across. Okay. That's the point of B in plan, and here is surface B. A is at an angle of 55 degrees in plan view. So what I'm going to do then is set up an angle of 55 degrees, which is there, and I'm going to draw a line. So now I know that A is along this line. Okay, now I know that the width of A now is 5 meters. Using sliding set squares then, slide that over. The thing then for A in plan view is that it's 6 meters deep from C. So I'm going to measure down here 6 meters. I'm going to draw a horizontal line across. And now I can do in that surface heavy. That's surface A. Now, if we moved into elevation then, we'll be able to set up the different surfaces. So project up that point, project up that point. Now it says that surface A has a pitch of 30 degrees. So I need to be able to show that pitch of 30 degrees. So what I'm going to do is I'm going to get an edge view now of surface A. So if I look down along here, surface A, and set up an X2, Y2 line here, I'll be able to put in my angle of 30 degrees. So draw in your line like that, project it out, and that'll give you then the height. Of A. There's your angle of 30 degrees. And that there then do now is we can take that height of that edge view on our compass, then in elevation, mark off that height. So that will allow us now to complete part of the elevation of A. We know that C has a pitch angle of 60 degrees. So what we're going to do now is we're going to project a view so I'm going to call that x3, y3. Now that has an angle of 60 degrees. We put that down, marker angle of 60 degrees. Now for this question we don't know the width of C in plan view, but we do know the height of C because B and C in elevation share the common height. So what we can do now is we can take that height from B and we can mark that height on C. So what I'm going to do now is draw a line parallel, project that across. Okay, so there now is the point at which it touches. So I bring this point now back down to BC. There's that line then in plan view from B to C. Okay, now we can project that now up to our elevation. The last thing now we need to figure out is we need to be able to figure out the intersection between surface A and surface B, so that point of intersection. Now down here in plan view we know that they share the same common height. What we need to do now is to get this line of intersection down here, if we take the height of surface A and over here then if we mark the height of surface A on this auxiliary view of B, so mark that height there. What we're going to do then is we're going to draw that then down to intersect that surface of B. So there's the point of intersection. What we're going to do now is bring that back then to our plan view. So there's that point right there, and then we join that up then to this point here. They share a common height at that point. We can bring that point now up to our elevation. I'm going to join that point then to there. Okay, so that is the first part of the question done. We had to draw the plan and elevation of surface A, B and C. So you can see now for the three different surfaces we had to use their pitch angle to get the height of each surface, so we'd be able to draw the elevation of them, and then more importantly then we had to use the height of A, because this is a common shared point between A and B. We had to take the height of A, mark it on the edge view of B to find that common shared point between both surfaces. B says develop the surfaces A and B. So to develop a surface, what you need to be able to do is you need to be able to get a true shape of that surface. So there's a couple of ways that you can do this type of a question. You can use rotation, you can use rebatment, or else you can get an edge view and look perpendicular to that edge view. I'm going to start with surface A. I have my edge view of surface A here, so what I'm going to do is I'm going to use the rebatment method. I'm going to rebat that plane or that surface A out here until it's horizontal, project it down and bring out my points from A. So the first thing I'm going to do is just extend out my x2, y2 line. So apologies for this now, it's going to go off the page slightly. Take that length of my compass. I'm going to rotate that around. there's the point there. Okay, so I'm going to project that now back at the same angle as A onto development. So there now is the true width of A. So again, set up the angle of A and project out my points. So that point is going to stay there, and that point is going to stay there because they're the hinge points of the point. So next thing I'm going to do now is I'm going to do the surface development of B. So again, there's lots of different ways that you can do this part of the question. I could look perpendicular to the edge view of surface B if I had room on my page, and I'd be able to set up an XY line and take my widths from here back, and that would draw the true shape of it. Or else I could do a rotation, or else I could do a rebattement. Again, probably the rebattement is the better way to approach this question. So again, what I'm going to do is I'm just going to extend down my x1, y1 line here, and I'm going to take the length of that and I'm going to rotate that out here. Me now the true width of B, and then I'm going to bring my lines from B down. So this point and this point here are the hinge points or rotation points, so it's the top points that I'm going to be just projecting down. So it's always perpendicular to your surface. Now I'm also going to have to rotate this point here. Okay, so get the compass, rotate that point there, and then project that across as well. So then that's that point there. The final thing that I have to do for this question is I have to find the dihedral angle between the surfaces A and B. So when you're dealing with the dihedral angle, you need to be able to identify the line of intersection between the surfaces. So there's the line of intersection in elevation, and there it is in plan view. So the first thing you have to do when you're doing these questions is you have to be able to get a true length of the line of intersection. Okay, so in order to get the true length of the line of intersection, you need to look perpendicular to that line. Once we've looked perpendicular to that line, then we're going to look along that line then to get a point view. So I don't want to be dealing with this big surface A and B. So what I'm going to do is I'm going to just make them surfaces a bit smaller and into triangular surfaces. So for B, I'm going to deal with this surface here. And then for A, what I'm going to do is I'm just going to draw a line horizontally across there. So I'm going to label that point there X, which is up there. Join them up in elevation. And then this is going to be called point Y. I'm going to project that up to elevation as well. What I'm going to do is I'm going to get the true length here over surface A, and then I'll be able to project it out here then to get my dihedral angle. So again, you have to look perpendicular to the surface. So what I'm going to do is get the angle of the surface. I'm going to project out my points. That's a common shared point between the two surfaces. And also that point out there. And I'm going to set up my XY line. So X4, Y4. So this point here is on the ground, so that's fine there. And now I need to get this point here. So I'm going to get the height of that. Then I'm going to mark that off then in this view. Now the height of Y is that same height as well, and then I'm going to get the height of X. So if I project out and then project out Y. So there's Y there. There's the line of intersection. So I'm going to join them up now to show the true length of my line of intersection. And then I need to get the X. So I've projected out X, get my compass and mark off that height of X. So X goes down to this point, and then Y, which is already there, goes down to there. So point Y now is very close to the line of intersection. So that now is true length of my line of intersection. Last part then is I'm going to look along that true length line. So I'm going to project it out here to get my dihedral angle. I'm going to put in a datum line through point Y, just so I want it to be taken full length. So datum line. So point Y then is on your datum line. So there's point Y there. Then I need to take the width from the datum line back to my line of intersection. And then I need to take the width back to X. And I mark that there. So join our points up. Point of view of the line of intersection. Hope it was clear and you're informed now as to how important the pitch angle, the length and the height are to be able to draw these surfaces in elevation and plan view, and the importance of looking along the surface to find these edge views to be able to put in the pitch angle. In terms of surface development, I hope you're able to see now the value of rebatting a surface onto a horizontal plane to be able to develop it. And then in terms of dihedral angle, then it's revision from the oblique plane, but what you need to do first is get a true length of the line of intersection. After that, then look along that true length line to get a point view of the line of intersection to determine your dihedral angle.